This screencast is being produced today for the module CA250. It's been carried out by the 5 individuals listed above: Claire Flynn, Brian Gibbons, Evan Cudden, David Cullen, Louis Burke. We chose the topic of bank PIN code safety and the storage of them on our phones. The screencast will cover the objectives of the assignment, the revision of key terms, outline the steps required to carry out the hypothesis testing, the worked examples of our hypothesis tests, and the verification of our findings. Our objective of the study was to determine whether half the population stored their PIN codes on their phones. This was carried out while ensuring that participants' identity remained anonymous by using randomized responses, an anonymous survey, and the deletion of data within a certain time frame. We use various terminology throughout this project, such as the level of significance conveyed by the sign alpha. The level of significance is the probability of rejecting a null hypothesis when it is true. The critical value, which is the point on the scale of the test statistic beyond which we reject the null hypothesis. The null hypothesis, which is a type of hypothesis used in statistics that proposes that no statistical significance exists in a set of given observations, while the alternative hypothesis is the hypothesis that is contrary to the null hypothesis. Therefore, if we reject the null hypothesis, we accept the alternative. It is usually used as a statement you wish to prove. While the steps in hypothesis testing using critical value approach begin with stating the null hypothesis and the alternative hypothesis. We then choose the level of significance alpha and find out the sample size. We determine the appropriate test statistic and the sampling distribution. We then determine the critical value of it, and then collect the data and compute the value of the test statistic. Finally, we make the statistical decision whether to accept or reject the null hypothesis. For the p-value approach, the first 3 steps are the same as the critical value approach. We then collect the data and compute the value of the test statistics and the p-value using the z-tables. We make the statistical decision. If the p-value is less than alpha, then we reject the null hypothesis, or if the p-value is greater than alpha, we do not reject the null hypothesis. An easy way to remember this is if the p-value is low, the null hypothesis must go. 3 main limitations in our project. The first one, the sample size. It was quite small due to the randomized responses, as it resulted in ignoring half the collected data. A larger sample size would have provided for more accurate results. While for the randomized response, 50% of the collected data were required to say yes, which made this data useless to us. And our survey participants involved mainly college students and or friends and family of the researchers, which meant that this could skew the results of the project. Our assumptions for the project were the 95% confidence interval, a 5% significant level, and instructions were followed correctly by the participants, and 50% of all answers will be answered yes due to the randomized responses. As this topic deals with sensitive information, we use randomized responses alongside an anonymous survey to protect participants. We decided to ask individuals if they were born in the first half of the year to answer honestly, and if they were born in the second half of the year to say yes. We as researchers had no idea what question was then answered, but assumed that there was a 50% chance of answering either question. As we used randomized response, we must assume that 50% of the participants answered yes to our question as they were born in the last half of the year. Therefore, using subtraction, we can estimate that 38 people who answered honestly, 11 of them at once stored a PIN code on their phones. We now must begin our own solution for our hypothesis testing. In step 1, we must state the null and alternative hypothesis. For this test, our null hypothesis is the proportion is less or equal to 0.5 or 50%, and our alternative hypothesis is that the proportion is greater than 50% or 0.5. For step 2, we choose a 5% level of significance and a sample size of 38. In step 3, we determined that we use the z-tables for a proportion test, and that our hypothesis would be one-tailed. As n pi and n 1 minus pi are greater than or equal to 5, the distribution can be approximated as normal. While in step 4, we established that the critical value was plus 1.64485. We then computed our data into the z-stat formula and came out with a result of minus 2.59554. Step 6 was to make the statistical decision, as minus 2.59554 falls within the range of non-rejection, we fail to reject the null hypothesis at a 95% significance level. Therefore, less than 50% of people at this level of significance store their bank PIN codes on their phones. Our p-value approach followed the same steps as the critical value approach from step 1 to 3, while our step 4 changed a little bit as we computed the value of the test statistic and the p-value. Our z-stat was minus 2.59554, which we assumed was very close to minus 2.6, so we found that the probability of z being greater than minus 2.6 was 0.99534. Therefore, our p-value was much greater than the 0.05 significance level, so we failed to reject the null hypothesis as well. As you can see, this is the Excel verification of our test, and our z-stat matches the z-stat that has been produced by Excel at minus 2.5955. Finally, to conclude, we figure out that since our z critical value is greater than our z-stat value, we must accept our null hypothesis, which means that our belief that over 50% of people store their PIN numbers on their phone was incorrect, thus meaning people are being safer with their PIN codes than we first believed.